Okay, hello everyone. Just want to record another supplemental video here to give you a little bit more information about working with arithmetic operators, types, and also to introduce something in C# known as the math class, which you can think of as basically just like a math object, kind of like what we looked at with strings already, that has a number of higher order math functions that you can use that are not available or that very difficult to achieve through just the use of the operators alone. So you can see I've already got a very simple project set up here. I'm not going to demonstrate the operators in math class with an actual program. And I did this on purpose in part because I want to show you how easy it is for you to just, fire up a scaffold, starting project, and then just with basically the console write line statement, start executing statements and expressions and just playing around with C# and the code and seeing what you can do. We don't often need full programs to test things. A lot of times just a simple program like this with some snippets, some comments can make it really easy. You'll also notice that the interface looks a bit different. I'm recording this video on my Mac because I'm quite frankly tired of the audio quality and issues I'm having with my capture software and my mic on the Windows machine. So for those of you that are Windows machine users, don't be alarmed. The process for creating the project, running the project, all of that's the same. And you've already seen that in several videos. So just apply what you know from Windows to your version if you're using Windows. And then those of you out there that have Macs, well, lucky you get a version of this with a Mac. So to kind of kick things off here, I'm just going to replace the scaffolded hello world directly with an expression. So the nice thing again about the write line method is it accepts a multitude of arguments, which we'll talk more about when we get into methods. But for now, all we need to know is that we can just very easily stuff arithmetic expressions directly into the write line method and see the results in the terminal. So if we had a very simple expression, let's build one so that we can deal with order of operations and precedence. Let's say we wanted 6 plus 4 divided by 2. We can just type this expression directly into the write line method. And because it is an expression, it'll be evaluated before the write line method executes, right? Because the write line can't take in an expression and then do something with it. It needs a value. So when we look at this, applying what we know about precedence and arithmetic operators, we can see that expressions are evaluated from left to right, but we know that division has a higher precedence than addition. So I would expect here that 4 divided by 2 would be evaluated first. So we would be left with 2, and then we would do a 6 plus, right? Then the addition operator would happen. So 6 plus 2 should yield 8. And we can execute this little program to see the output. And sure enough, there is our 8. So we can see that that works, right? And again, just use little expressions, little programs like this to test theories you might have, execute some brief code statements, and that'll help you kind of pick up the language and understand it better. Now, if in fact what we wanted to have happen was the addition before the division, of course, we know that we can use parentheses to raise the level of precedence or to group lower operations together. Sometimes it also makes sense, even if the operators are in the proper order and due to precedence, they'll execute the way that you want them to. Sometimes it makes a lot of sense to still wrap parts of an expression in parentheses just to be explicit about what the operations groupings are. So anyways, once we've wrapped this 6 plus 4 within its parentheses, we've kind of now grouped this operator. So now I would expect 6 plus 4 to occur and then the divide by 2. So 10 from this operation and then divided by 2, I would expect to yield a value of 5. Okay, and there we go. Perfect. So far, so good. I don't think we're breaking any real new ground here. Now, one thing I do want to bring in here, this is a good opportunity, is if we modify this expression ever so slightly, so that now instead of 6 plus 4, it's 6 plus 5, that's going to yield an 11. And 11 divided by 2 is not 5, right? We're going to have some decimal precision here. And So now it's a matter of, okay, well, what do we think the result is going to be that we get written out, and what is the actual result? So I'll give you a second to think about it. You can pause the video and try to work it out. But if we run this program with a simple change, you'll see that we still get the same result, the 5. So 6 plus 4 divided by 2 is equivalent to 6 plus 5 divided by 2. And of course, we know that that's not really true. But the reason for the result coming out the way that it is because all of the values in this expression are integers. They're all whole numbers. And so when you have an expression that makes use of only integer values, the result itself is also going to be an integer. Okay? Now, if we wanted to have the fractional precision, the decimal precision in the result, what we would need to do is, at a minimum, change one of these values to a larger or more precise type. So, for example, by putting a .0 on the 2 value, we've now converted that from an int into a double. So you'll notice here on the pop-up it tells us now, oh, it's a system double versus a system int 32. And so by including a double in the expression, that will force the computer to yield a result that is in the type of whatever the largest or most precise type used in the expression is. So this is enough, it turns out, to take our 11 and divide it by this double value to yield a double. And so now by putting this 0.0 on and executing the same program, we'll now see that we get 5.5. So now we're getting some decimal precision, but we have to be aware of the data types that are being used. So if you're ever creating some arithmetic expressions and you're not getting the results you expect, have a look at the types of the data that's being used. Okay. Now, one final point on this before I move on and talk a little bit about the modulus operator is the value that's yielded here now is 5.5. And so when we go back to just integer values and we run this little program, the result here is a 5, right? 5.5 doesn't get rounded up to 6. The 0.5 simply gets cut off, okay, or what we call truncated. And so that's important to know too, is that if you have an expression that yields what would yield typically a fractional result, the computer is not going to round that value up. Okay, so even if the value that came out of an expression was 2.9, when you convert 2.9 to an int, it's going to be converted to 2. Okay, whatever the decimal precision piece of that number is, when it's converted to an integer, it's just blown away. It just gets truncated and cut off. So you can use that to your advantage if you understand the rules and how the types are how they behave to do certain things within a program. So don't right away take the idea that, oh, that's a bad thing, I really want it to round. It turns out there are mechanisms to round it. The math class, which we're going to look at in a moment here, has a round method that we can use. But it's important to understand how the types are going to work in C#. Okay, so that's a little bit about types and order of operations. And now I want to introduce an operator that's not often used, but in situations where it's useful, it's extremely useful to use. And that is the modulus or the remainder operator. So using that same example, if we take 11 divided by 2, okay, we've just seen that the result of this we would expect to be a 5 as an integer value, but the remainder from that division operation would be a value of 1. Okay, 5 times 2 would give 10, right? But there's still that 1 from the 11 left over. So 11 divided by 2 is 5 with a remainder of 1. And if for some reason you were interested in that remainder value, rather than do the division and then subtract the result from your quotient here, then you could just call the modulus operator and you could get that remainder value straight away. So 11 divided by 2 is going to yield what we would already expect, is a 5. Okay, and if instead of the 5, again, we wanted the remainder of that operation, we can replace the slash with the percent symbol. Okay, and the percent symbol is the modulus or the remainder operator. And so by making that simple change and they're in the same program, it's no longer going to give us a value of 5, we get 1, right? Because 1 is the remainder. And some of you might be thinking, like, why is that useful? And it can be useful for many things. For example, in this example here, I was able to actually get the value of whatever was in the ones column. But also, I'm able to, in this case, do a modulus 2 to determine whether or not a value is even or odd. Because if something is evenly divisible by 2, so let's take 10. 10 modulus 2 is going to yield a remainder of 0. So I could check the result of this mod 2 expression, and if that value is 0, I know that it's an even value, okay? But if the remainder is a 1, then I know that it's an odd number, an odd value. So we can use it for things like that, or just checking whether things are evenly divisible by other numbers, but also for yielding different parts of numbers. So when it comes to programming and numbers, don't always think about it in terms of straight arithmetic. Sometimes it's just a matter of how we can play with the values to tweak them or pull them apart and inspect different pieces and things about them. And sometimes those are quite useful in ways that you've never had to explore before because you've never programmed before. So that's a little bit about how that works. Okay, and now the final thing that I want to demonstrate here is the use of the math class. Okay, so for example, there's some things we haven't really talked about yet, like how would you get the square root of a number? Or how would you implement exponents? How would you raise a value to the power of some other value? And there are no operators that we can use to do that. So for those higher order math functions, we can use the capital M math class. Okay, so if you type in capital M math, you'll see it gives a little pop-up here. That's our math class. And the description is exactly correct. It provides constants, so values that might be useful. So if you were doing some formulas that require the value of pi, then you can get that to a very strong, significant number of digits from the math class, okay? And it also provides a number of, like it says here, methods for trigonometric, logarithmic, and other common mathematical functions. So we access those methods in the same kind of way that we access string methods by hitting the dot operator, okay? And then once you do that, you can see a pop-up menu here in IntelliSense that shows all the different properties and properties and methods that are available. So the constant e, for example, right? But then there are other methods. So whether things are equals, which is on the object itself. But if you needed to do logarithms, right? So there's log functions here. If you wanted to check the maximum number between two values, you could do stuff like that. But what we're interested in right now are things like raising a number to the power of something else. And so when you're dealing with exponents, the method you want is math.pow, okay? And math.pow takes two parameters, okay? The first parameter is the base, and the second parameter is the power. So if we wanted to raise 3 to the power of 2, let's say, we would call this method, and we would pass in 3, the base, comma, space 2, and pass in the power. And so 3 times 3 should yield 9. 3 to the power of 2 should yield 9. So if we run this, we should see that that's exactly how this method works. So there's our value of 9. So if you have exponents in an arithmetic formula that you need to carry out, math.pow is what you want. Okay, and sometimes you're also going to want the square root, another common function. So square root is SQRT, capital S. And again here, we just pass in the value that we'd like the square root from. So if I want the square root of 9, kind of the opposite of what we just did, raising 3 to the power of 2, we can pass in a value or variable or expression that yields a value. And sure enough, we see the square root of 9 is 3. Okay, so the math class is quite useful for things like this. And like I mentioned earlier, if you're interested in rounding something, there's also a round function there too, a round method, which we don't need right now, but will be introduced later on in the course. So there's lots of other methods in here. Like I said, there are constants, like for the constant pi, which it shows you what that value is recorded here. So there's lots of stuff in the math class. I invite you to explore. If you're a math head, you want to do something unique in your programs that involve some more complex mathematics, then the math class might have methods that are useful for you. So that's it. That's all I wanted to talk about in this brief supplemental video. Explore the math class, have fun with expressions and precedence and the different operators, and I'll see you next time.